Hello and welcome. My name is Elhelw. Today I'm going to talk about a somewhat advanced feature of SQL, and that is window functions. Window functions sometimes are also referred to as analytical functions. These are typically used in analytical queries, that's hence the name. And they can be a bit confusing to some people if they're not used to using them or if they haven't seen them before. But hopefully this video will clear up some of that confusion and make them easier to use and make it easier for people to understand how to use them, what to use them for, what are the different syntax options, and so on. Window functions, they provide some advanced capabilities that you can either not achieve without them, or you can achieve without them sometimes using other SQL constructs like aggregation, joins, subqueries, and so on. But in many of these cases, if you try to do it without using window function, you end up with queries that are much more complex, much more difficult to understand, and that are obviously more prone to errors and bugs and so on. So by using window functions, you can usually simplify your queries a lot and make them easier to understand and maintain. But before getting into window functions, let's look at some regular examples without window functions and then go from there. So this is the table that we have. We have an employees table with 25 rows. It has ID column, name, department, salary of each employee, and the hire date of that employee. Now we can do a simple aggregation. Let's say we want to calculate the average of all the salaries in this table. Then we can simply do select average of salary from employees. So if you run this, we get a single value that has the average of all the salaries of the employees table. Basically, all the rows have been collapsed into one row that has the average value. We can also do this for each department separately. So we can add the department here, and then we can group by department. So if we run this, we'll get multiple rows, one row for each department. So basically each department has been collapsed into one row with the average salaries of that department. So in this example, we've seen how to use just aggregation to get the average of the salary either across the whole table or per department. To get it per department, we use the group by clause. So this is the query that we had, and this is the result that it produced. And in those cases, as you all know, aggregation and group by basically collapses some of the input rows into a single row. So in this case, if we're grouping by department, so all the rows that have the same department value, for example, the security department, will be collapsed into a single row that has the average value of the salary in this case. The same thing with the IT department, the same thing with sales, and so on. So each group of rows that have the same grouping key are collapsed into a single output row. But what if we want to compute these averages without collapsing the inputs, right? So basically, what if I want to compute the averages and then attach them to the original rows? So for each row that has security department, I wanted to also display the average for that security department, which is 3,300. I could want to do this because maybe I want to see for each employee whether they get paid more or less than the average of that department, for example, or something like that, right? Can we do this with just aggregation or without window functions? One way to do this would be to take the result that we've just computed here and then join it with the original employees table based on the department. This will give us what we're looking for. So we can use this as a CTE, for example. So I can say with department average as this CTE, and then I can select from employees E join department average DA, and let me call this average sal. So we're going to join these two tables on E dot department equals DA dot department, and then we're going to select ID name E dot department salary and also average sal. So basically we're selecting the columns from the original employees table, and we're also selecting this average sal that we calculated, and we're joining this subquery with the employees table on the department. So if we run this, we get this result. So we have the 4 columns from the original table. We didn't return the hire date here, and then we have this average sal column, which has the department averages, right? So the security department has an average salary of 3,300. So you'll see that 3,300 repeated for every row that has security department, because we're joining based on the department value. And then for the IT department, we have 3340. Again, all the rows that has IT have the 3340 in them, and the same applies for the other departments as well. So this is one way to return this kind of results that we're looking for. And just for the sake of curiosity, if we add explain here to see what the plan looks like, so you can see that we had 2 sequential scan on employees, one because of the subquery, so we're scanning employees here, and then we're scanning employees again in the main query outside, and we have a join between the two. So this is what the plan for this query would look like. So as we saw in the example, we can do what we wanted to do using just group by, join, subqueries, and so on. Of course, this is not the simplest way to write a query like this. Of course, this is, a very simple example, but if you try to do that same thing with more complex, let's say, queries or more complex tables and so on, things can get more complicated. An easier way to do this would be using window functions. Window functions are a group of SQL functions. They are able to split the input rows into windows, or which are basically just groups, and then compute some function on these groups without collapsing them into a single row. This is the main advantage and the main difference between window functions and regular aggregation, is that they compute the result of the function without collapsing the input rows into a single row. Basically, the result of the window function is produced as another column, which is attached to the original rows, as we have seen in the previous example. Window functions include many different kinds of functions. Some of them are actually the same aggregate functions that we have seen before, sum, average, min, max, count, stuff like that, but they are used in a different way. It also includes some other functions that we have not seen, and we cannot use those functions except as window functions. The main syntax that tells the system that we want to use something as a window function is using a clause that we call the over clause. So let's see what that looks like in the examples. I'm just going to write how to do this. Don't worry about the syntax for now. I will explain this later, but just follow with me. So we can do select, ID, name, department, salary. These are the original columns. And then I'm going to write, this is the new part, I'm going to say average of salary over partition by department, and then from employees. So if I run this query, this is the result that we get. The order of the rows is a little different, but we have still the same values. So if we look at the security department that we've seen before, again, all the rows that have security have that 3300 average. All the IT rows have the 3340 average, and so on and so forth. We can also remove this partition by, and this will give us the same value across all the tables. So this is the average for all the salaries in the whole table, and it attaches it to every single row that we have. If I add that again, so here again, now we have these averages computed separately for every department. One might ask, what is this useful for? What can we use this for? One thing you could do, for example, is, I don't know, like say you want to find out all the employees that are getting paid more than the average salary in their department. So you could use something like this, and then you can use a subquery and say, select star from this subquery where salary, this is the individual salary of each employee, is greater than, let me call this average salary. So this is greater than average salary. So here, for each department, it will show you all the employees that are paid more than the average of that department. So you have, for the engineering department, the average salary is 3,200. So everyone who's paid more than 3,200 is going to appear in the results. For the HR department, the average is 3,760. So everyone who is getting paid more than that in the HR department is going to appear in the results, and so on. So now we have seen how to get the same result using a window function. But someone may ask, okay, well, if we were able to accomplish the same thing without a window function before, why do we need window functions? Why can't I just live my life without knowing window functions and do everything in that same way before, right? First, as we have seen, the query looks a lot simpler, right? We just did select some columns and then the window function from table. We did not have any group, we didn't have any join, we didn't have any subquery, anything like that. So the query looks a lot simpler, easier to understand, easier to maintain, less, less possibility of introducing errors or bugs into the query and so on. The second is that sometimes it can be actually very difficult to write this without a window function. In our case, we had a subquery that included the employees table, and then we rejoined that with the employees table again. What if that data was not already in a table? Like what if that, instead of having it as a table, what if that came from a different query? We would have to either basically repeat that whole query twice, or we would have to execute that query separately, store the results in a temp table, and then call that table twice, which is a lot of extra I/O. We could have also used it as a CTE, which would either run it twice or again materialize the results somewhere. So it's again the same thing. So it introduces some complexity. It can also introduce some performance, make the performance worse. So these are things to keep in mind of why is it sometimes necessary or preferable to use window functions. As we've seen, the main thing that tells the system that we're using a window function is using that over clause. The over clause can be empty, which means that we're treating the whole table as a single group. So whatever window functions that you're applying, we're going to apply it on the single table as a whole group. Or we can use the partition by clause within the over clause, the partition by some column. This tells the system that yes, we are going to use a window function, but we're going to split the data into multiple groups based on the value in that column, and we're going to apply the window function on each group separately. So we've seen both in the previous example. The first class of window functions, which we have already seen, was the regular aggregate functions. Sum, count, min, max, average, and so on. So we can use those functions as window functions once we specify the over clause beside them. And we've already seen that, but let's see more examples about that as well. We can use the same way to also return other aggregate functions besides average. So let me try this with min and max, for example. So for each department, I want the minimum of the salaries in that department. I'm going to call this min sal. And also, I want to get the maximum salary, again, partitioned by department. And I'm going to call this max sal. So if we run this query again for each row in the employees table, get the original columns plus min sal and max sal. So again, for everyone in the engineering department, for example, the minimum is 2,600, the maximum is 4,200. So as we can see here in the actual data, the smallest value here is 2,600, which is the minimum, and the largest one is the 4,200, which is the maximum. And the same thing applies for every department, again, because we're partitioning by the department in this case. You could also do a sum, for example. So let me take out one of these rows and just put sum. So this will give me the sum of the salaries in each department. Again, we still have partition by department. So for the engineering department, the sum of the salaries is 16,000. For HR is like 18,800 and so on and so forth. And like before, if we remove the partition by, now the window function is over the whole table. So then the sum here is 86,600. This is repeated for all the rows in the table. We don't have any partitioning in this case. One new thing to try, even though we already know the partition by, there is another thing that we can do here. We can say order by. So let's say I want to order by the hire date, for example, and let me also print out the hire date here. So what does that mean? What does it mean to put order by inside the over clause? Order by here means it dictates the order in which this aggregation is going to be performed. It also slightly changes the meaning or the semantics of the aggregate window functions, because now it becomes a running aggregate, meaning that it's not the same value for every row, but it's computed only on the rows that we have seen so far. So let me show you what this means. If I run this query, we don't have partitioning, so now we're working on the whole table, but you can see that the sum is not the same value for the whole table. The sum here is actually a running sum. So for the first row, we're ordering by hire date, so the smallest hire date is the beginning. So for the first row, the sum is just of this value. For the second row, the sum is of the first two values. For the third row, the sum is of the first three values. So for each row, the sum is of all the values that we've seen so far. So by the time we reach the end of the table, then this final sum is of all the salary values that we have here. So this depends on how we specify the order by. We can also still do that with partition by. So if we add the partition by that we are familiar with, let's say we partition by department. So this means that we are doing this computation for every department separately, but within each department, it's going to be also a running sum. So we run this query. Now we can see, okay, we have the engineering department rows, and here we have a running sum. So only this value appears here. Both those two values sum up to 5,500. Those three values sum up to 8,500, and so on and so forth. And then when we start a new department, then we start from the beginning again. So this 4,000 is just because it's the single row here. And then this one is because we have two rows. This one is because we have three rows, and so on. So we can combine order by and partition by when we're using the aggregate window functions to give us this effect of a running aggregation. We can also use this with other aggregate functions. So if I replace sum with min, for example, so this means that we are getting the minimum value within each department, but it's a running minimum in this case. So let's say again for engineering, the first row we have only seen one value so far, so this is the minimum. Now, by the time we get to the second row, we have seen these two values, so the minimum out of these two is 2,600. By the third row, we've seen these three values, so the minimum is still 2,600. So everything pretty much like until the end of these 5 rows, the minimum will remain 2,600 because this is the smallest salary in this department. And then when we start the next department, HR, we start from the beginning again. So here the minimum is only of the 4,000 here, and then seeing this, the minimum is still 4,000. Seeing this, the minimum now is 3,200, and so on. So again, the same concept applies regardless of which aggregate function we're using. Like I said earlier, aside from the aggregate functions, there are other classes of functions that are only used as window functions. The first such group of functions is something that I like to call ranking functions. So these are a few functions like row number, rank, dense rank, ntile, and others, but these are maybe the most famous ones. So this group of functions basically helps us assign ranks or some identifiers to each row based on some ranking mechanism. Let's see what that looks like. All right, let's try to look at the ranking functions, and let's start with the row number. So I'm going to write row number. This function does not take any arguments. And as a window function, we have to specify the over clause. So if I run this query, we can see that basically it just assigns a unique row number for each row. So row number 1, 2, 3, 4, etc., all the way to 25. So this is useful if you want to just assign some unique numbers and then use them for something else. Of course, here we did not have order by, so these rows could be ordered in any fashion. Maybe if you run the same query multiple times, you might get different order, but we can also use the order by clause as we have seen before. So let's say I want to order by the salary, for example, and I will order it in a descending order. So if I run this, here we have the salaries ordered from the greatest to the smallest, and we have the rows number assigned. So basically, the employee with row number 1 is the highest paid employee in the company, and they're ordered by this. The ranking or the row numbering here indicates how high they are paid. So the last one has the lowest salary that we have. The next function I wanted to talk about is the rank function. So I'll keep this one here and then add rank over order by salary, also descending. We don't have to specify the same over clause, but I'm just specifying the same here to be able to compare the outputs. So if we run this query, now we have these two columns, right? So we have the row numbers that we've seen before, and also now we have these rank values. It's somewhat similar with some exceptions. The exceptions mainly are in the cases where we have repetition. So because we're ordering by salary, the value of salary dictates the rank. It also dictates the row number. But in the case of ranking, when we use the rank function, the rows that have the same salary value will get the same rank. So both the first and the second row get a rank of 1. And also, when there is repetition, we skip some values. So the third row, it doesn't get a rank of 2, it gets a rank of 3. Simply because Carlos, there are 2 other employees before Carlos, so Carlos is rank number 3. So that's why they get 3. Donnie has the same salary as Carlos, so it also gets rank number 3. And now we have to skip number 4, so the next one becomes 5. Both these two have the same values, so they both get 5. We have to skip number 6, so the next one gets 7. There is no repetition here, so the next one is 8, 9, 9 repeats, so now we have to skip 10, and the next one becomes 11, and so on. If we have more repetitions, so for example, these 3 all have the same value, so all of them get 15. Now we have to skip 16 and 17, so the next one becomes 18. So this is what the rank function does. A similar function is called dense rank. So if we run it now, so it also gives the same rank to the ones that have the same value, so both these get 1, but this one does not skip values, so the next one gets number 2. So there's no skipping happening, even though we may have many repetitions. So even in this case, when these 3 had the same value, so all of them get number 11, but the next one gets number 12. So again, here it's slightly different. Same values get the same rank, but it does not skip any values. Another useful function is called ntile, and this one actually takes an argument, takes a number, like, let's put 4 for now, and then we'll see what it does. So what ntile does basically is that it splits the input into a number of groups based on the number that we have here, and assigns a value, basically the group number for each set of rows. So here we want to split them into 4 groups. So some rows will get number 1, some rows will get number 2 until 4. So if we run the query, so you will see these group of rows have number 1, these have number 2, these have number 3, and these have number 4, and it tries to split it evenly across the different values. Of course, the more you specify here, the more groups that you have. They may not have the exact number of equal rows, obviously, because let's say we have 25 rows here, 25 is not divisible by 4. So there might be a group with 1 extra row or something. So it tries to make it as close as possible. So this is usually useful for some of the analytical queries where you want to split things into quantiles, like say the second quantile, stuff like that. So you can specify how many groups you want to split data into. All right, let me remove many of these and just keep the rank function for now. So here is the rank function that we have seen before. Of course, we can also use this with partition by, as we have seen. So if I add partition by, let's say partition by department, then again, this means that we are going to compute the value of the rank function within each department. So if I run the query now, so we can see within the engineering department, this is the ranking that we have. And then within the HR department, we have this ranking. And again, notice that these two, because they have the same value, they get the same rank within the same department. Of course, if they have the same value across multiple departments, it doesn't matter because we're computing things within each department separately. And let's say, just as an example, if I want to find out the 2 top paid employees in each department, so we can use something like this. Since we already ranked them by their salary, we can say, okay, like out of this subquery, give me the top 2 employees in each department. So that would be, so from this subquery where the rank that I just computed is less than or equal to 2. So here it will give me the rows that have rank equals 1 or 2 in each case. So I can use this to get, let's say, the top 2 or the top 5 employees based on their salary and so on. Of course, you could do this also without window functions. You could just order by salary and do a limit or something like that. So there are different ways to achieve this. The next couple of functions that I want to talk about, and these will actually be the last functions for today, are the lag and lead functions. These are functions that allow us to access values or data from previous or upcoming rows. It's a little bit difficult to understand without seeing an example, so let's just jump into the examples. All right, looking at our original table again, selecting all the columns from this table. Here is the table that we have. Now let's try to see the lag window function. So the lag window function returns a value from the preceding row. So what does that mean? If I say, so salary, comma, lag, let's say salary as well, over order by hire date. So if I run this, let me call this as lag 1. So basically here, okay, so without the lag, we have ID, name, department, hire date, and salary. Now the lag tells me, okay, I want the value of the salary from the previous row. So for each row, let me look at row number 2. Here you have 4,000, which is the value of the salary from the previous row. Here you have 2,400, which is the value of the salary from the previous row. The first row, since it does not have a previous row, That's why we see a null here. So all the rows will have the value of the previous row except for the first one, which will produce a null. We can do similar thing with the lead function. So the lead function is the opposite. It gives you the value from the following row. So if I say lead salary over order by hire date as lead 1. So now we have, this is the lag values and these are the lead values. So for the first row, this is the value of the salary from the next row, which is this one. Here, this is the value of the salary from the next row, which is this one. And then for the final row, since there is no next, then the lead will return null. This is very useful when you want to compare values from multiple rows, but actually return them on the same row so that you can do other operations on top of that. You can, I don't know, do a difference, or you can do a comparison greater than, less than, to see who's getting more or less than the previous employee and so on. Of course, you can also do this per group or per department. So if I do, partition by department in this case for both of them. So if I run the query now, let me just expand this a little bit. So now for each department, again, because we're partitioning by the department, you can see here that we have the lag and the lead values, and now we have the nulls per department. So for this row, for example, it does not have a previous one. This row doesn't have a next row within the same group. It may have a next row outside the group, but because we're computing only within that group, it does not have a next row, so that's why we see a value of null in this case. Okay, let me replace actually the lead here with the lag as well, and let me call this lag2. So right now they both should return the same values. Now I'm going to add an offset. What does that mean? So far, the lag or lead functions are returning the things from the previous or the next row right away. What if I want to skip something? So instead of returning the previous immediate row, I want to return, the row before the previous. So skipping 2 rows rather than just 1. So I can add an offset of 2 or 3 or 5 or whatever value I want. So this means instead of looking just 1 row behind, now look 2 rows behind. So when I run this, lag1 still has the default, which is an offset of 1, but lag2 has an offset of 2. So the first row does not have 2 rows, before it. This one also does not have 2 rows before it. But this one gets me the value of 2 rows ago. So I get this salary value from the first row. The fourth row gives me the value from row number 2. The fifth row gives me the value from row number 3. So again, there's a gap of 2 here instead of a gap of 1, which is the default. And again, the wider the gap, the more nulls we start to see. On the topic of nulls, we can actually replace those nulls with a default value. So if I don't want to see all those nulls, we can specify a default value. So I can say, I don't know, 0, for example. It's an easy one. So if I run this, all the nulls here are replaced with zeros. So again, this is something you can do if you want to get a specific value when it's a null. You cannot specify the null value, you cannot specify the default value without the offset. So if I want to specify a default for the first case, I have to put the offset first, even though it's a 1. So I could say 1, and then, I don't know, the default value can be -1, just because. So if I run this, you'll get the -1 as the default value in those cases. So like we've seen, those two functions, lag and lead, they allow us to compare or first of all, retrieve values from either the preceding or the following rows. They could be directly preceding or following or with some offset like we've seen, and then basically produce all of these values on the same row. This allows us to do things like, comparisons. We can compare, let's say, the salary of the current, employee with the salary of the previous or the next employee. We could do things like, some arithmetic operations on them. You could do comparison operations. You can do whatever you want on them once they are all in the same row together. So we will stop here in this video. We will continue talking about window functions in the next video, but let's summarize what we talked about today. So today we have started or introduced the concept of window functions. Window functions split the input rows into groups, or they can operate on the whole input as a single group if we want to, and they produce additional information based on each function. These additional values are attached to the rows that we have without being collapsed into a single row like traditional aggregation. We've seen the syntax that we use to specify window functions, which is basically we write the function name, We write the aggregate, the arguments of that function if it takes arguments, and then we specify the over clause. The over clause can be either empty, which would indicate that we're operating on the whole table or the whole input as a single group, or it could have partition by a specific column, which will tell us how to split that input into multiple groups and operate on each group separately. We could also put the order by some column, which will tell us the order in which the window function is being evaluated, again, either on each partition or on the whole table as a single group. We talked about different categories of window functions. The first category was the aggregate functions, but being used with the over clause. We've seen how it can aggregate values over the whole table and then produce the results, beside each row, either over the whole table or within each group. We also saw how to use them as a running aggregate if we specify the order by clause as well inside over. The second category that we talked about was the ranking functions, row number, rank, dense rank, ntile, and we saw how they assign different values to different rows. And finally, we talked about lag and lead function, which give us access to values from either the preceding or the following rows and including them on the same row that we have to be able to do further operations on them. We will continue talking about window functions in the next video, but for now, if you have any questions and comments, please let me know. Hit the like button if you like this video, subscribe to the channel if you haven't done so already, and with that, thank you so much for watching, and I will see you in the next video.